Bismillahirrahmanirrahim. Assalamu alaikum. Okay, let's continue with the functions. We have discussed functions already, but to continue with the functions, let's see what we have already discussed. Suppose we have a function to have a perfect square of a number. And we have number over here 2, 3, 4, and it's our function, and we denote it with f. This is our domain, this is our codomain, and here we have 4, 9, 16. So what's happening here? We are linking 2 with this, 3 with this, 4 with this. So what is function? Basically it is you input something to the function and you get output. This function is regarding the square of a number, so you are inputting some number to a function and that function is giving you a square, right? In this case, if we are supposing we are writing f2, and what do we get? 4. We input 2 to the function and we get 4. Okay, if we input 4, we get 16. So the input is 4 and we get 16. Okay, so this was the basic we have already discussed. So let's take an example of functions and then we'll move towards inverse of a function. Okay, as an example, we have a function f from x to x square minus 3. And the function f x is equal to this. We have to find the value of this. If this is the function, we are inputting this, what are we going to do? We are going to replace x with x square minus 3 because it's a function from x to x square minus 3. So f x square minus 3 is equal to 4 into x square minus 3 square. We are replacing x with x square minus 3 minus 5 into x square minus 3 and then plus 2. So we have replaced, what have we done? We have replaced x with x square minus 3. So here we are going to apply an identity to simplify it. Here it's just a multiplication, if you remember. It's a distributive law of multiplication, and then we have a constant over here. So 4 into, so let's square this first. So instead of a we have x squared. So what do we get? x4, then minus 2ab. So 2 into x squared and then minus 3. Right? So minus 2ab, so 2 into x square into 3. So 6x square and then plus 3 square, which is 9. And then minus 5x square and plus 15 and plus 2. Right? Okay, so let's simplify it. We're going to multiply this with 4. So it is 4x4 minus 24x square plus 36 minus 5x square plus 15 and plus 2. Right? So this is the only one x4 term. So we are going to write it as it is, 4x4. This and this both are negative, both are x square terms. So this is minus 29x square. And then what we have? 36 plus 15. It's, what is it? 51. Okay. And 51 and 2 plus 53. So after simplifying, this is the result. Now let's discuss what is inverse function. Okay. Okay, for the inverse of a function, let's take the same example. Two, 3, 4, 4, 9 and 16. So this was the function from domain to codomain, and when we input a number we get a square. Now we are talking about an inverse of a function. So inverse, the arrows are reversed. First it was from domain to codomain, now from codomain to domain. So this is inverse of a function. And what is happening? Now the arrows are from this direction. And in this case it was like this. If you input 2, what you get? 4. Now in this inverse of a function, if I input 4, because the direction of the arrows is reversed, so if I input 4, what do I get? 2. You see, here input was 2 and I got a squared number. Here the squared number was the input and I got the under root of that number, right? Input was 4 and I got 2. So this is the inverse of a function. Now let's take some examples of this inverse of a function and try to understand how it is working. Okay. Okay, we have an example over here. It's a function from x to 8x plus 3. So first thing is, this is a function, so we can write it like this: fx is equal to 8x plus 3. If x is the input, the output is 8x plus 3. Okay. But what we have to do, we have to find f inverse x, right? So it's not like this that I'm going to put here f inverse over x and solve it. No, not like that. So to solve it, we're going to assume that this term is equal to some variable, and so let's suppose y is equal to 8x plus 3. Now since this 8x plus 3 is equal to y, so definitely I can write it like this. Therefore fx is equal to y, because if this is equal to 8x plus 3, so I can write it like this. Now it's the time to get the inverse. So x is equal to f inverse y. Okay. If this is as we were doing initially, that we can the arrows are reversed, so the arrows are reversed, so this is f inverse y. Now what do I need? I need this x. Okay, and from where I can get this x? From here. Okay, if I say this was my equation 1, so from equation 1, what do I need? I need to have x. So y minus 3 is equal to 8x, and then x is equal to y minus 3 over 8. Okay, now instead of this x, I can replace it with this x value. Okay, so if I say this is 2, so from 2, or you can say using equation 2, y minus 3 over 8 is equal to f inverse y. Now this variable y is a dummy variable, Now since y is a dummy variable, it could be any variable, right? So it's a variable. So I can write it like this: f inverse x is equal to x minus 3 over 8. So this is the inverse value. So whenever this is a situation, you have a term, take another variable, equate it to that variable, and then try to get the inverse by using this methodology, and you can never be wrong. So, okay, so it's simple. Let's take another example to understand what we are doing. Okay. Okay, here we have another example. Function from x from x to 3x minus 1 divided by x minus 2. Function x from x to from x to 3x minus 1 to divided by 3x minus 2, right? Function from x to 3x minus 1, x minus 2. Now I said it correctly. Okay. Okay, now the first thing is that why here we have x not equal to 2. It's because if x is equal to 2, 2 minus 2 becomes 0, and if you divide anything with 0, it's undefined, right? So it cannot be 0. So this is the first condition. Now we have to find f inverse x, but here we have a term again. So first thing is that let's write it in a proper function form. Fx is equal to 3x minus 1, x minus 2. Now we are going to suppose let y is equal to 3x minus 1 over x minus 2. So this is our term, so we cannot apply directly to the inverse function. So what we do is we introduce another variable and we say that variable is equal to this term. Now if this is equal to y, so what we can say here, therefore fx, this y goes there, is equal to y. Now the inverse thing, so x is equal to f inverse y, right? So we have inverse here. Now what do we need? We need x values, and to get the x values we're going to use this equation. So from equation 1, y into x minus 2 is equal to 3x minus 1. So yx minus 2y is equal to 3x minus 1. So let's take x values on one side and y values on the other side, because we need x, we have to find the value of the variable x. So yx minus 3x is equal to 2y minus 1. This goes over that side and 3x comes to this side. So x is common, y minus 3 is equal to 2y minus 1. So x is equal to 2y minus 1 over y minus 3. So this is the value of x, right? So let's substitute this value over here, and we have here 2y minus 1 over y minus 3 is equal to f inverse y. And since now this is a dummy variable, this implies f inverse x is equal to 2x minus 1 over x minus 3. So solved, done. Okay. So this was the inverse of a function. Hope you have got the idea and you can solve it yourself. Okay, thank you.